So far we have our graph started, we found a lot of points on our graph, and now we have our table of values almost filled in. We have to use our vertex formula to find the actual vertex. So remember the vertex, that's that thing down at the bottom, the very smallest point there, or very lowest. Maybe it's the highest if the parabola is going the other way. For this one, it is our lowest point. Let's use our formula. So the formula says that the x value of the vertex is always going to equal negative b over 2a. And remember, your a, b, and c come from your standard form. The standard form of this problem, which we already found in the last video, was y equals x squared minus 4x plus 3. So that means my a value is that number out in front of my x squared term. My a equals 1. And my b is going to equal negative 4. That's the number in front of my x term. And of course, that would be my c value if I were to try to find it. That's where you can get your y-intercept. Let's fill that in. X then will equal negative my b term, which was a negative 4, divided by 2 times my a term. And that gets me positive 4, positive 4 over a positive 2, which is 2. Ooh la la, my x value of my vertex is 2, so that means whatever I get here, that's going to be my vertex. Let's do it! So I'm going to plug in 2, my x equals 2, into my standard form. Sure, love it, can't wait, never been so excited in my life. Y equals 2 squared minus 4 times 2 plus 3. 2 squared is 4. Minus 8 plus 3. Negative 4 plus 3. Negative 1. Negative 1 is the y value of my vertex, everybody. So my vertex is 2, negative 1. It says, doesn't match my graph. I don't know, look over there. Does it make sense? Yeah, it looks great. That totally makes sense that my vertex would be 2, negative 1. Cool. Then it says, what's the line of symmetry? Remember, your line of symmetry is that dotted line that goes down the middle. Your line of symmetry is always an x equals line. It's just the x value of your vertex every single time. So that's my line of symmetry is x equals 2. It always matches the vertex. Okay. The parabola can also be written as x minus 2 squared minus 1. So if it asks me to verify that they are equivalent, I just have to use algebra rules until they actually say the exact same thing. So I'm trying to get this y equals x minus 2 squared minus 1, and I want that to be equal to my standard form, which is x squared minus 4x plus 3. So let's see if we can do that. The first thing I can do here is I can rewrite my x minus 2 squared as x minus 2 times x minus 2. And that's what happened to the left side. By the way, I'm just going to ignore this. Ignore this for now. Who cares? All right. X squared minus 4x plus 3. Let's see. Are those equivalent? I'm going to FOIL now. My first two numbers multiplied together. My outside 2. My inside 2. And my last 2. Negative times a negative is a positive. I'm leaving the right side of this equation the same. I didn't do anything to it. And now let's combine like terms. Our negative 2 and our negative 2, these two guys. X squared minus 4x. And then 4 minus 1 is 3. Ho, ho, we're in such good shape. Check it out. Check it out. They're the same. We did it! Yay!